Okay, so in the previous video we introduced the binomial series, which again is the sum as k goes from 0 to infinity of p choose k, x to the k, which again will converge as long as the absolute value of x is less than 1 to 1 plus x raised to the p power. So we want to use that with p equals 1/2 now to approximate square root of 1.1 with 4 terms. Okay, so we have, of course, square root of 1.1 can be thought of as 1 plus 0.1 raised to the 1/2. So here x is going to eventually be 0.1 when we plug it in, and the exponent will be 1/2. So square root of 1 plus x, we can think of as 1 plus x to the 1/2, which using the binomial series would be the sum as k goes from 0 to infinity of 1/2, choose k, x to the k. We want to approximate this with 4 terms. So the first 4 terms of our series now. Right, so k equals 0, 1, 2, and 3. So to do that, that means we needed to compute these 1/2, choose our different numbers. Now remember, p choose 0 is always 1. Right, p choose 0 is always going to be 1. Then we need 1/2 choose 1. Remember, that'll always be whatever we're choosing, will be that factorial on the bottom. So 1, however many terms you have at the bottom, that's how many we have at the top. So on the top, we would just have the 1 as well. And so that would just be 1/2. That would just be 1/2. And then 1/2 choose 2. That will be 2 factorial on the bottom. 2 times 1. On the top, we would have 1/2 times 1/2 minus 1. So in the end, we're going to have a negative 1/4 divided by 2 be negative 1/8. And then finally, 1/2 choose 3. We'll have 3 factorial on the bottom. 3 times 2 times 1. On top, that'll be negative 1, or sorry, not negative 1/2. That'll be 1/2 times negative 1/2 times negative 3/2. On top, that'll simplify to be negative 3 over 8. And then that's all being divided by 6. What will happen is the 3 on top will cancel with that 3 and the 6 and leave you with another 2 on the bottom. So in the end, we're going to get a positive 1/16. Positive 1/16. So our approximate polynomial now would be that the square root of 1 plus x is approximately 1 x to the 0 plus 1/2 x to the first minus 1/8 x squared plus 1/16 x to the third. And we're going to evaluate that when x is equal to 0.1. Go to that expression, plug in 0.1, and then we're going to go back and compare that to our result. So bring up my calculator here. 1 plus 1/2 times 0.1 minus 1/8 times 0.1 squared plus 1/16 times 0.1 now raised to the third power. I get 1.0488125. 1.0488125. And let's compare that, let's contrast that with the actual square root of 1, which is 1.488. So we're pretty close. If we go up to, out to 4 decimal places, we are in agreement. And in fact, even rounding, if we rounded to 5 decimal places, we would be in agreement. And it's the 6th decimal place right now where we are losing some accuracy. But that's pretty darn accurate for just a simple 3-term polynomial, or 3rd-degree polynomial approximation to the square root of 1 plus x. And you can see if we go to the graphical scenario, y equals square root of 1 plus x. On one hand, looks like that. And on the other hand, our thing looks like this. 1 plus 1/2 x minus 1/8 x squared plus 1/16 x to the third. And you can see how, at least for a little while, especially if you're, in this neighborhood between -1 and 1, it's pretty close, at least around here, and then getting close to 1. The blue graph again is fairly close to overlapping with the red graph. Okay, and then it's not. And then it's not. Okay, a little bit less so on this side towards -1, and this side towards 1, where it's actually fairly closer. Okay. So again, we can get more accurate by increasing the number of terms. The more terms, the more accurate we would be. Okay, so that's just an example of using the binomial series, the power series, binomial series, and cutting it off, approximating it. We did a similar thing with square root in the past with Taylor polynomials. All right, so that is an example of using our binomial series to approximate something.